Okay, in this video what we're going to do is we're going to solve a radical expression and solve for and check the solutions to see if they are extraneous. An extraneous solution spelled E-X-T-R-A-N-E-O-U-S. An extraneous solution is a solution that is illegal or invalid. So it doesn't make sense. Okay? So what we're going to do is we're going to go through a few problems here and we're going to check our answers to see if they're extraneous. And as we're going through it, I'll explain just exactly how it is or is not extraneous. So the first problem we're going to attempt is the square root of 3x minus 2 equals 7. Okay? And what we're going to do is we're going to try to solve this. The way we would solve it normally is we would square both sides, and we would get 3x minus 2 equals 49. We would add 2 to both sides, and that would give us 3x equals 51. If we divide by 3, we get x equals 17. And that looks perfectly legitimate, right? X equals 17, it's a nice number. Let's try it. Let's see. So to check to see if it's extraneous, what we do is we take the answer and we plug it back into its original problem. So the check is we take 3 and we multiply it by our x, which is 17. So we're going to do 3 times 17 minus 2. And we want to see, is it or is it not going to equal 7 the way that we say it's going to? Okay? So we're going to do the square root of 3 times 17 is 51 minus 2 equals 7. So we get the square root of 49 equals 7, and so we get 7 equals 7. That checks, so the answer x equals 17 is valid. We would not consider it extraneous. Let's try another one. It is the square root of 2x minus 15 equals 49. And to solve this, what we would do is we would add 15 to both sides, and we get the square root of 2x equals what? The square, let's see here. We would add 15 and we would get 64. We would then square both sides, and that will give us 2x equals this really big number. It is 16, carry a 1, 24, 25, 0 times is 4, carry a 2, 36, 38, 6, 9, 0, 1. It would equal 4096. And if we divided both sides by 2, we would get x equals 2048. And that looks perfectly legitimate. So what we would do to see if it's extraneous is we would go back and plug it in. So we would do 2 times 2048 minus 15 and check to see if it equals 49. 2 times 2048 we already determined is 4096. Minus 15 is 49. So we would get 64 minus 15 is 49. 49 equals 49. So this answer checks. So if x is 2048, we get a valid solution. Big number, but still it's valid. Okay. So let's try another one. And in the next one, we get x minus 6 equals the square root of 8x. Okay. What we want to do is we want to square both sides to solve. And x minus 6 is x minus 6 times x minus 6, which is going to equal 8x. This side becomes x squared minus 12x plus 36 equals 8x. We would subtract 8x from both sides to get x squared minus 20x plus 36 equals 0. So then what we would do is we would factor this side into x minus 18 and x minus 2 equals 0. So our solutions are positive 2 and positive 18. To check if the answers are extraneous, what we do is we go back up to the original problem and we plug in x equals 2 and we plug in x equals 18. If we put in the 2, we get 2 minus 6 equals the square root of 8 times 2. We get negative 4 equals the square root of 16. Negative 4 equals 4. This is not possible. This is illegal. This is an invalid answer, right? Because x is 4, or our right side is equaling 4, our left side is equaling negative 4. Those are not the same answers, so we would say that that answer is invalid or extraneous. Okay? Then we would try our other answer, and we would get 18 minus 6 equals the square root of 8 times 18. So we get 12 equals the square root of 144. 12 equals 12. This answer checks, so this is a valid solution. Let's try another one. Okay, so again, what we do is we solve it, and then we take our two answers and we plug it back into the original problem to see if it makes sense. That's what extraneous solution is all about. Is it valid or is it not? If it is not valid, it's extraneous. If it is valid, then it's a valid answer, and you just move on. That's your answer. So the next one we want to try is x equals let's see here, the square root of, what is that number? 2x plus 35. So x equals the square root of 2x plus 35. First thing we want to do is square both sides to get rid of the radical. So we get x squared equals 2x plus 35. We have a quadratic, so we have to move everything to the one side. So we get x squared minus 2x minus 35 equals 0. We would then factor this number. The two numbers that multiply to give you negative 35, that add to give you negative 2, are x minus 7 and x plus 5. So we get the answers of negative 5 and positive 7. We now want to try both of these answers in the original problem. So our original problem is x equals the square root of 2x plus 35. And we're going to try first negative 5, and then we'll try x equals positive 7. If we put in negative 5, we get negative 5 equals the square root of 2 times negative 5 plus 35. So we get negative 5 equals the square root of negative 10 plus 35. Negative 5 equals the square root of 25. Negative 5 equals positive 5, right? Because the square root of 25 is positive 5, we would say that this answer yields an extraneous solution. So we would throw it out. We would say, okay, we're not going to let x be this negative 5 because it yields an invalid answer. Then we'll take the 7 and plug it in, and we get 7 equals the square root of 2 times 7 plus 35. So 7 equals the square root of 49. 7 equals 7. That checks. So this is a valid solution. X equals 7 checks. the x equals -5 is extraneous because it fails the check. Now we'll try. Now I'm going to stop this video and I'm going to start another one because it gets really complicated in the next two problems, and you're probably going to play this next one over and over and over to see how this next problem is worked out.